In this section, I'm going to talk about energy lines and how they can really help understand the pressure losses along a pipe network. So everything is kind of nicely illustrated in this image, which I'm just going to talk around. So we have a tank here on the left hand side, and this is the level of the tank here. And water is flowing into the tank on the right hand side, and this is the level of the water in this tank. And what you're looking at is connected between the two pipes. There's a larger diameter pipe, a pump, a valve, a sudden expansion to a larger diameter, then a sort of slow contraction into a narrow diameter pipe, and then finally it exits into this tank. So you can see there's a number of losses along here. There's an entrance loss, there's friction along this diameter pipe, there's a valve, there's a sudden expansion, there's losses due to the contraction here, again friction in this pipe, and then the exit loss. Now, if you look at the blue and the red lines above the system, what they're showing you is relative to distance along the system, so between the two tanks. It's showing how the pressure or energy or head, remember these terms are relatively interchangeable. So you think back to Bernoulli's, we derived Bernoulli's based on energy, but we expressed it in terms of pressure, and we can also express it in terms of head. So in this example, we're going to think of it in terms of head. Okay, so the head in this tank is obviously at the level, and then the head in this tank is at this level, and the difference between the two is the head loss. And if you want to think of it in terms of pressure, you can, but remember, just to get from pressure to head, you divide by rho g. And what the blue line does is it kind of shows you how the head changes between the first tank and the second tank, and where the losses occur. The red line kind of follows the blue line, but you can see that the difference is basically the dynamic head. Okay, so not dynamic pressure, it's divided by rho g, so the dynamic head. And you've also got the kind of potential head sort of shown here as well. So let's go from left to right, and hopefully this will start making sense in terms of the losses. So just inside the pipe here, the head is kind of equal to the head of the water level. But you can see, due to the entry loss, there's immediate loss in pressure or head. Okay, so it jumps down immediately, and you can see it's kind of what's shown by this sort of gradient here is how the water accelerates into that pipe. So this is, as say, the difference between these two lines is effectively a dynamic head. So you can see that that's increasing as the velocity of the flow is increasing. You can then see in this pipe, between the entry loss, between the entry to the pipe and the pump, there's a gradual loss of energy or loss of head, and that is due to the friction in that pipe. And then see at the pump, we actually get a pressure rise, and I will talk about that in another lecture. So there's electron hydraulic machines where we talk about the pressure rise due to pumps. So you can see the energy or pressure or head is put into this system. Then it continues to decrease as it goes between, due to the friction between the pump and the valve. There's a sudden decrease as it goes over the valve. There's a head loss associated with the valve. Then there's another another gradual decrease between the valve and the sudden expansion due to friction. Then there's a sudden head loss due to this sudden expansion here. Then in this pipe, you can see that there's friction loss again here due to water flowing through this pipe. But notice here that the change between the sort of total head and the dynamic head is less because water's flowing slow in here, so therefore the dynamic pressure is less. Then there's losses associated with the water flowing out from this gradual contraction, and then you see here that the gradient also changes, and that's because there's going to be a higher that indicates that there's higher frictional losses in this pipe due to the change in diameter and perhaps change in material as well. So there's higher, the change in diameter, there's higher frictional losses in here. To eventually get to the end, and then there's a final pressure loss or head loss due to the minor exit loss till we get to the final head in the other tank. So this kind of plot is, I think, is quite nice. Hopefully I've explained it, and you can see that it encompasses all the things. So you can really see how the pressure or the head is lost as we go through this series of pressure loss elements from, for example, one tank to the other. Okay, so that concludes this lecture. Thanks for listening.